All right, this brings us to question number 29. It deals with air traffic control. Good news is they gave you a picture of what was going on. All right. Um, so we have two planes flying inwards towards a certain point. All right. Now, in the solutions manual, they labeled the diagram that they gave in the solutions manual. They labeled it accordingly. Here, they gave you the distance between the two planes is s. All right. Now, as these planes fly inwards towards a certain point, which is here, as they fly inwards towards that point, then you see the dotted line? You could see that the distance between them is getting shorter and shorter. All right. So that distance is decreasing. All right. So we definitely know therefore that the rate of change between the two planes is decreasing, and they actually give you that here in the problem right here. All right. We know that for the fact that the distance between them is also decreasing. That's why. All right. Now, they labeled in the solutions manual, they labeled this side right here, which is, they labeled it Y. All right. It should make sense. And they labeled this here X. All right. Now, you don't have to label it Y or X, but it was just convenient. All right. Because we're thinking the X axis here and we're thinking the Y axis there. Okay. But you could have labeled this A, B, doesn't really matter. Anyway, let's see. This is very similar to the problem that I gave you with the cars. All right. Only thing, one of the cars was going that way and the other one was going inwards. All right. This time, both things are going inwards towards each other. All right. Now, what do we need to find? Now that we've labeled the diagram appropriately, right? So we have labels. You can see that this side here is decreasing as the plane goes in, and we can also see that the Y side is also decreasing as it flies towards the origin. All right. So what do we need to find? Well, for A, let's look at A. It's asking you find the rate at which the distance between the two planes are decreasing. So the distance is s. So to find this rate of change, we're trying to find ds dt. That should make sense to you. All right. Now, so find the rate at which the distance between the two planes are decreasing. Alrighty. So, what else do we need to find? Well, what's given to us? All right. There's some rates that are given to us here. One plane is 225 miles from a point and it's moving. Okay. All right. So here's a rate of change, and you know that represents a derivative. All right. So we're given that one plane is moving at 450 miles per hour and it's 225. All right. So this represents this plane right here at the bottom. Okay. This represents this. So therefore, the rate of change or the speed of this plane is represented by dx dt. So we're given that the speed of this plane is represented by dx dt, and that would be 450 miles per hour. All right, 450 miles per hour. Good. Right, because we know it has to be this plane, because you can see that the plane is right at 225 miles away from this point. Okay, the other plane is 300 miles from the point, so it has to be this guy because it's 300 miles, right, away from there. So therefore, it's telling you that this plane is flying at a speed of 600 miles per hour. All right. So therefore, the speed of this plane in terms of a derivative is given by dy dt. All right. So we're given these two rates. So it's very similar to the car problem that we did in class. So that is let me see, 600. Now I deliberately made a mistake here, because if you didn't see it, then you should see by now. These two rates that I just wrote down, the two speeds of the planes, right? Well, do they have to be negative or positive? Well, first of all, how do you figure it out? X, the plane is going in, so X is decreasing. Okay, so therefore its rate of change is also decreasing. So we have to put in negative for that one. And also y is decreasing. So therefore its rate of change is also decreasing. So we have to put a negative there. That makes the world of difference when we plug that into our related rates equation. Okay, so you needed those two negatives right there. All right. Now we need to okay, so let's now I'm sure that you can see that this involves a Pythagorean theorem problem, because we're going to try and relate all these three variables together, s, x, and y, and we should come up with the Pythagorean theorem. All right, so we should get x squared plus y squared equals s squared. All right, the hypotenuse squared right here. And if we take the derivative of this, both left and right here, it becomes just like that problem with the cars. We should get 2x times the derivative of x with respect to time. We get 2 dx dt plus, then put the 2 in front of the y, subtract 1 times the derivative of y with respect to dt, or respect to time. And then also note the derivative of this guy times ds dt. Okay, so we should be getting that. Okay, now what else do we need here? We need to find ds dt. Okay, now I don't know if you see a 2 here everywhere. All right, if I factored out a 2 from here, these 2's would cancel out. All right, so if you're wondering how the book kind of jumped something right here, well, they kind of jumped a step right here. Remember, I'm trying to find this guy. We're trying to find this right here. Okay, so ds dt. All right, so basically the book solved this guy for ds dt. All right, now so to solve this here, I'm just going to divide everywhere by 2s. Okay, just divide everywhere by 2s. So I'm going to get 2x dx dt plus 2y. Did I say 2x? I'm sorry, this should be 2s. All right, kind of I'm doing this very quickly because YouTube has a time limit on it. All right, so I'm going to get ds dt right here, and I'm dividing all of that by 2s. Okay, now we can cancel out 2's here. If I factor out 2 from here and here, you'd have a 2 on the outside and everything in parentheses, and then the 2's would cancel out. Okay, so basically these 2's cancel out everywhere. All right, so if you're wondering how they got that in the solutions manual, that's what they did. All right, they canceled out 2's everywhere right there. Okay, so that's good math. Now we're trying to find this guy, right? The rate of change of the distance between the two planes, and it's based on these things right here. Now we need to know something else. We have something for dx dt, which is that. We have something for dy dt, which is that. But we need to know what x, y, and s is at a certain point in time. All right, and it's given to you in the problem. It's saying what one plane is 225 miles from a point, right? And the other one is 300. So we're going to use that fact here. All right, we have to use that fact. When x is equal to, so let me see here. When x is equal to 225, that's given by this here. All right, so this right here represents 225. When x is 225, and when y, which is this here, is let me see, 300. So this here, when y is 300, okay, well, what would the distance be between the two planes at that point? Okay, what would the distance be? All right, So we have to find S when X is 225 and when Y is 300. Okay? So then this becomes a Pythagorean theorem problem. Okay? So here we're going to use this guy now. All right? So we're going to be putting in 225 here plus 300 here equals S squared. All right. So we're going to get some pretty, this is where the calculator comes in handy. We're going to have 225 squared plus 300 squared equals S squared. All right. So then to find S, you have to take the square root of all of that. All right. So S is going to be the square root of all of that, what we just found here. Now, I don't have a calculator handy, but I do have the solutions manual handy. So S should work out to be, according to the solution manual, 375. When you do all the math right here in the number crunching, you're going to get S is equal to 375. All right. So now we got S, we got X, we got Y. So it's all a matter of just plugging all of that information into this formula right here that they have in the book. All right. So you end up with, let me write it out now, ds dt equals, so x is going to be, let me see here, x was 225, all right, dx dt was negative, all right, so that's where they got the negative, because remember it's a decreasing rate, plus y, well, y is 300 times dy dt, this guy right here, and that was given by the speed of that plane, all right, which is negative. It's negative. You had to put in a negative there, all right, over s, all over s, and s we just figured out by using the Pythagorean theorem, so that would be 375. Then you put all of that good stuff in your calculator, which I won't be because I don't have the time, but it should work out to be negative 750 miles per hour, according to the solutions math. So hope that was right, because I didn't even check it myself, but I know you guys will. And that's the speed or the rate of change of the distance between these two planes, because we know this S is getting smaller and smaller, and it's getting smaller by a rate of 750 miles per hour. And that's the rate of change between the two distances. All right. So, or I shouldn't say between the distances, but between the two planes, the distance between the two planes. Okay. Now, part B, I'm going to have to do in a separate video. So look out for part B, because I don't want to go over the time, because there's a time limit on YouTube. Okay. So hopefully that helped you. And we're going to wrap it up right now. If I can only find the right button. So F9.